Welcome back to another AP Pre-Calc video. Again, I'm Mr. Hibble. Today we're still in the conversation of 1.10. We're still looking at rational functions. But today we're going to start going more in depth on slant asymptotes. Okay, it's still an asymptote. It's still a line that your graph's going to approach as you go towards either infinity in the x direction. But a slant asymptote, right, it's at an angle instead of a horizontal or vertical asymptote that we've been looking at. Remember, slant asymptotes occur whenever the top has a degree that is one larger than the bottom. Notice the degree on top in this case is 3. The degree on top on the bottom is 2. So the degree on top is one larger, just like we'd want for a slant asymptote. So let's go ahead, let's find the slant asymptote for this function. How you can find a slant asymptote is simply by dividing. We can actually perform the operation of dividing this rational function out. For example, I can take the x squared minus x plus 1, put that in front of my long division symbol, and then all of this other stuff is underneath. Just like we were doing the other day, we want to figure out how to make x squared the same as x cubed. Well, if I multiplied that by x, that would work for me. But that x, remember, needs to multiply with all three things in the front. X times x squared is x cubed. X times negative x is negative x squared. And x times 1 is simply 1x. The x up top multiplied with all three terms in front. When we do that, we can then subtract these functions to see what that gives us. Oh, my marker's working again. Remember, the first term should always go away, and then we just want to see what we're left with. 2x squared minus negative x squared. Remember, you do have to be careful to see what that gives you. Minus a negative is actually just adding there, so we get 3x squared. 5 minus 1x, that ends up giving us positive 4x. Bring everything else down. So now I need 3x squared to match x squared. Well, I could multiply that by 3. Really, to find a slant asymptote, once you have your two terms, you have the x term and the constant, like we have right now, you really don't have to take this process any further. All we need is those two values to give us the equation of the slant asymptote. If you did continue this, though, realize you would end up getting something like this, where we could then subtract and find our final values. Okay, negative 9 minus 3 would be negative 12. Okay, but again, I don't care for the remainder. I just need the equation that we were left with, which is the x plus 3. So what we just found is our rational function that we were given originally has a slant asymptote at y equals the quotient. Well, the quotient, the values we found were 1x plus 3. So just to show you what that type of asymptote looks like, I went ahead and graphed the rational function as well as the asymptote. Notice as we go off towards infinity, our graph, the red line, the rational function, gets super close to that blue line, but it never actually crosses it. It's just going to get infinitely close to it. That is the idea of an asymptote. You get close to it, you approach it as you go towards the infinities. Okay? There's our graph, the rational function with the asymptote. You can always check to see if you did these problems correctly by graphing it on Desmos or something like that. Another thing we can do when we're looking at these types of problems is maybe we just want to determine all of the different key features, right? So maybe I'm given something like this. I notice there's holes at x equals 1. X equals negative 1, sorry, right? The canceled term is our hole. We can factor the top to see what we have. One thing you might do is notice the top, it's negative x squared. Personally, I don't like to factor whenever my a value is negative. So the first thing I generally do is just take that negative out. If you take it out of the x squared, you take it out of each of the terms. And now I think this problem is a lot easier to factor. Do you have to do it that way? No, but it is one of the ways we can factor. Then I need two numbers that multiply to positive 1 but add to negative 2. I believe negative 1 and negative 1. It does not look like anything else cancels. So now we can look at the wholes, the vertical asymptotes, the horizontal, the slant asymptotes, the intercepts, and so forth. Okay, I'm not going to worry about finding a y-intercept on this one, just an x-intercept. So let's look at this stuff. Vertical asymptote, bottom equal to 0. Well, x minus 3 equal to 0. That would just give me x equals 3. Horizontal asymptote, whether you look at the original function or at the ending function, the degree on top would be bigger than the degree on bottom. When the degree on top is bigger, that means we do not have a horizontal asymptote. However, what I want you to notice is the top's degree, yes, it is bigger, but it's more specifically one value bigger. So that means there is a slant asymptote that we would have to divide out to find. We'll do that step last. X-intercepts, take the top, set it equal to 0. Both of them are the same for both of your parentheses, so it would be x equals 1 and x equals 1. Well, that's just one x-intercept where your graph would bounce at that spot, right? Because that is really just x minus 1 squared. So we know our root, it would bounce at that x-intercept. Let's look at the slant asymptote now. In order to find the slant asymptote, you can start at the beginning function or the ending function, depending which one you think is easier. However, the one thing that has to be true is whatever you're looking at has to be multiplied together. So I think looking at the middle might be the easiest here. I would have x minus 3 out front. Underneath, if you distributed that negative 1, we'd have negative x squared plus 2x minus 1. And now we can start to divide to find the slant asymptote. Find what you need to multiply x with to be negative x squared. Then you can multiply that in. Go through your subtraction. 2 minus 3 is negative 1x. Bring down your next term. Go through your multiplication again. To make x negative 1x, you'd have to multiply by negative 1. Make sure you distribute that to both of your terms in front. And then subtract. And we end up getting our remainder. Again, I don't need the remainder. I just needed this part where our slant asymptote is y equals negative x minus 1. That is the 1.10 video talking about slant asymptotes, giving us a little review about finding all of the different key features as well. That's it for me. Thank you for watching.